Professor Kleinium to describe for you a lab we did recently in class. This lab was on the decomposition of sodium hydrogen carbonate. The way this lab is set up, I have three possible chemical reactions, only one of which is the true and real chemical reaction. And the point is to try to figure out which is the true chemical reaction using stoichiometry. So this is the first chemical reaction, reaction number 1. Maybe you could try this, write it down on your paper, and then in a moment I'll put the answer up here. Okay, this is the answer to the first one. Sodium hydrogen carbonate decomposes into solid sodium hydroxide and carbon dioxide gas. So that's the first one. Second reaction is sodium hydrogen carbonate decomposes into sodium oxide, solid, and carbon dioxide gas and water gas. Take a second and do that on your paper. Okay, so this is the answer. Sodium hydrogen carbonate decomposes into sodium oxide, Na2O, and carbon dioxide and water. Notice the balances. It was a 2, 1, 2, 1. And here's the third chemical reaction. Sodium hydrogen carbonate decomposes into sodium carbonate, solid, carbon dioxide gas, and water gas. Take a second and write down this balanced chemical reaction. So the answer to this one is 2 sodium hydrogen carbonates decompose into 1 sodium carbonate, Na2CO3, and 1 carbon dioxide and water. So in this lab we have these three possible chemical reactions, only one of which is the true chemical reaction. So the task is to try to figure out by stoichiometry, taking a sample of this of a certain known mass, and then heating it up, decomposing it, which of these three substances, sodium hydroxide, sodium oxide, or sodium carbonate, proves to be the correct answer. Okay, now to solve this, what I did was I took some sodium bicarbonate. I started out with 5.5 grams. This is my lab value that I weighed out. When I cooked it thoroughly, I got a new value, which was 3.5 grams of some product. Now I don't know which product it is yet, but hypothetically it could be sodium hydroxide, sodium oxide, or sodium carbonate, given those former three equations that I showed you. So now what I need to do is I need to theoretically, using those balanced chemical equations, knowing I have the same amount of reactant, how many grams of product would I make in each case, and then the number that is matching this number is it represents the correct formula. So what I do first of all is I have to convert from grams of sodium bicarbonate or sodium hydrogen carbonate. I know that there are 84 grams of sodium hydrogen carbonate is 1 mole of sodium hydrogen carbonate. Then according to my balanced chemical equation, 1 mole of sodium hydrogen carbonate produces 1 mole of sodium hydroxide. Now I have to convert from moles of sodium hydroxide to grams of sodium hydroxide. The formula for sodium hydroxide is 40 grams per mole. When I do the calculation, I get a theoretical amount of 2.6 grams of sodium hydroxide. So that's not a very good match. Trying again, the first part will be identical. 84 grams of sodium hydrogen carbonate is 1 mole of sodium hydrogen carbonate. Now in this case, it was a 2-to-1 ratio. 2 moles of sodium hydrogen carbonate would make 1 mole of the theoretical product, sodium oxide, and 1 mole of sodium oxide, is equal to 62 grams of sodium oxide. Again, remember these numbers are all coming from the periodic table, the formula mass, all added up. Do the math here, and I got a theoretical of 2.0 grams, even less, and an even worse match than this. Finally, we have this one where I'm going to make sodium carbonate. So again, the same value would go here. The mole ratio, like before, it's 2 moles of sodium hydrogen carbonate. That's coming from the balanced chemical reaction, would make 1 mole of sodium carbonate. So now I'm solving for the third and last potential product, and 1 mole of sodium carbonate weighs 106 grams. When I do the math here, I get 3.5 grams, which proves to be a perfect match to the lab value. So now I can definitely conclude that the third equation, equation number 3, is the correct equation because I got a very good result. In fact, when I plug that into the percent composition, I get my lab value, 3.5 grams, divided by my theoretical value, 3.5 grams, times 100, gives me, of course, 100% yield. So I got a very good result, and it just proves that, of course, these two reactions are not the true reaction, and the true reaction is this one, proven by the perfect match between the theoretical value. This is, of course, is the value you get from just theory and math against the lab value that I got from actually heating up the sodium hydrogen carbonate and getting a value for the product.